Okay, now we're going to convert a polar equation to rectangular. So remember, if we can get something to be our cosine, that converts to x, and our sine, that converts to y. So this cotangent and cosecant, first thing we're going to do is we're going to convert cotangent to cosine over sine and cosecant to 1 over sine. Well, sine times sine is sine squared. So to separate the cosine over the sine squared, we're going to multiply both sides by sine squared, which is what we did right there. Now look at what we have. We have sine squared times r. So if I all I did here was rearrange and wrote it as r times sine squared. If we multiply both sides by r, I now have 3r cosine. Well, r cosine converts to x. And r squared sine squared is the same as r sine theta times r sine theta, because r squared sine squared, r sine is y times y squared. So now you have y squared is equal to 3x. Since the y is squared, that means we want to get the x by itself. So divide both sides by 3, and then I'm just going to flop the sides. I mean, this would say x is equal to y squared over 3, but that's difficult to read backwards. And then this graph right here, on a polar graph, they would look the same, right? Let's look at this one. So if this was cotangent cosecant, and that equaled x equals y squared, if you've got tan secant, it's going to end up y equaling x squared. So notice the difference. An up or down parabola is when it's tangent secant, and when it's a sideways parabola, it will be cotangent cosecant. Those are thetas in there. I didn't write them, but same with here. I should have written the thetas. All right, so let's see what we did there. We converted the sine over tangent to sine over cosine, secant to 1 over cosine. Cosine times cosine is cosine squared. We multiplied both sides by cosine squared. Then I multiplied both sides by r. R sine converts to y. R squared cosine squared means the same thing as this. R cosine, which is x. Another r cosine equals x, so that's x squared. I divided both sides by 4. And then just rewrote it the way our brains like to see it. Y is equal to x squared over 4. So that is just a wider upward facing parabola. So if this would have been on a polar graph, it would have been the same graph. So if you put that into Desmos, it would be the same. Okay, let me go down here. Well, now you've got a plus and a subtract. So this is going to be a little bit dicey here, maybe. First thing I did is I grouped this by putting in parentheses, multiplied by both sides, because r squared I can immediately convert to x squared plus y squared. Well, since I'm multiplying this side by r cosine converts to x, r sine converts to y, so 2x, 2y. Since this is x squared plus y squared, we want to get the x's and the y's over to the other side. So we subtracted 2x, subtracted 2y. So this zeroes out on this side. And when I subtract it, I'm going to put the subtract 2x right next to the x squared. And then I'm going to put a plus blank, because for both of these, we're going to complete the square. And then y squared, I put the subtract 2y next to the y squared plus blank equals 0 plus blank plus blank. When I complete the square, remember the c is equal to b divided by 2 squared. Well, negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So we added the 1 here, we added the 1 here, but we also have to add the 1 to both sides. 1 plus 1 is 2. And now look at what you have. You have x minus 1 squared plus y minus 1 squared is equal to 2. So that's a circle with center 1, 1. I do not know how to get rid of that, but okay, there we go. And there you have it. On this one, it's pretty, oops, doggone it. Okay, for this one, all we have is a negative 4r sign. So if I multiply both sides by r, well then I have r squared equals negative 4r sine. That converts to y. And r squared converts to x squared plus y squared. So now all we're going to do is add 4y to both sides. So the x squared, we don't have to complete. That's just going to be x squared. And then to complete the square, when you have a 4y, half of 4 is 2. 2 squared is 4. So then we add 4 to both sides. And then this completed square, oh, I forgot to say that over here. Once you have a completed square, it factors to binomial squared. And then you know what shape you have. You have a circle. And then right here, same. This right here, this simplifies to a binomial squared. And again, we still have a circle, but this time the x-coordinate of the center of the circle will just be 0 because there's not a parentheses. And then the opposite of positive 2 is negative 2. And then the radius, the square root of 4, is 2. All right, let's see if there's a different type. Go down a little bit. Okay, these are the ones that get a little bit dicey. When you see a theta equal, just know you use tangent as an operator. You take tangent of both sides. And then remember, this is just a fact you're going to have to memorize at all of the pi 6's. So pi 6, 5 pi 6, 7 pi 6, 11 pi 6, and then at all of the pi thirds. At all the pi 6's, tangent will either be positive or negative root 3 over 3. At all of the pi thirds, tangent will be positive or negative root 3. This is 150, which is 5 pi 6. So 1/2 divided by negative root 3 over 2 simplifies to this. In the second quadrant, tangent is negative. Remember, tangent is positive in third, and all trig are positive in the first. So in the second, tangent is going to be negative root 3 over 2. All right, so now we're going to convert tangent to sine over cosine. And then to separate the sine and cosine, we're going to multiply both sides by cosine. And then we're going to multiply both sides by r. Because remember, the whole point is to get it back to x and y. So r sine, we can now convert to y. And then negative root 3 over 2, r cosine can be converted to x. And now you just have this negative line whose slope is negative root 3 over 3. All right, I think I'm going to show you the steps on this one. So a little bit dicier because that's a double angle. So I wrote this as 1 over 2 theta, which is, and I converted the one that I chose, remember cosine 2 theta, the double angle, has three options. Cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 cosine squared. So I chose that because it's easy to separate the cosine and the sine. I divided both sides by r squared. And then I multiplied. I did the distributive, r squared times cosine squared, r squared times sine squared. And now look at, I now have r squared times cosine squared converts to x squared, subtract, r squared sine squared converts to y squared, and I'm going to put this invisible 1 over here. Now that we have a fraction equal to a fraction, I can flip both sides. And now I just have 1 is equal to x squared minus y squared over the invisible 1. That's just a hyperbola whose center, because there's nothing in the parentheses with the x and y, whose center is 0, 0, and to graph it, to sketch it, you go over the square root of 1 is 1, and you go up. The square root of 1 is 1, and then you draw that invisible square, and then you draw the diagonals through the square. And because the x is positive, for hyperbola, when the x is positive, the graph opens to the left and right towards the x-axis. If it would have been y squared minus x squared, it would open towards the y-axis. All right, that is it for the different polar to rectangular equations.